Hello friends, I am Dr. Vishwadeep Tripathi. I am making this video as an assignment in a faculty development program at Kerala University. So in today's lecture, I will explain some very interesting chemistry regarding the synthesis of dendrimers and how these dendrimers are applied in the field of search of an antitubercular molecules. This is the work which I did in France in an Indo-French collaboration work with a collaboration with Professor Jean-Pierre Majorel and Sashmik Nani and Anne-Marie Caminard. So let's begin. Why the dendrimers are important and why chemists are very fascinated to work in the field of dendrimer synthesis. The reason comes behind this highly symmetrical and big structure of dendrimers. You can see the dendrimers is highly symmetrical and have the various branches at the surfaces, and if we perform the chemistry at the branches by changing the surface of the dendrimers can also use in various fields of application. Like it is reported that dendrimers are using in the field of hybrid materials, in the field of nanochemistry, in the field of optics, organometallic chemistry, chemical sensors, agrochemicals, fluorescence, transfection, and DNA chips. So, how a single molecule can be applied in this diverse field? This is the reason behind the fact that there is a surface around the dendrimer, and if we perform the chemistry on these surfaces, we can change the properties of surfaces from cationic to anionic to neutral, and by changing these properties, the application of these dendrimers will change in different fields. In fact, the name dendrimers for this molecule has arisen from the word that dendrons. Dendrons means trees, it's a Greek word. So, let's see how these dendrimers can be used in different fields. What I was explaining in last slide, that these phosphorus dendrimers have diverse application. Like when the surface is anionic, it has the anti-inflammatory applications. When the surface is neutral, it has the application in catalysis, fluorescent properties, and with the cationic surface, it has the application in transfection agents, RNA delivery, prion replication inhibition, etc. So let's begin with the principle of dendrimer synthesis. What is the principle behind the dendrimer synthesis? Is actually the synthesis of dendrimer is a step by step process. In each step, we grow the dendrimer one by one by one by one. This is the main difference between the polymer and the dendrimer. Polymer synthesized by the polymerization process. In a single reaction, we can get the polymer, but in the dendrimer, the condition is not same. See, we have the core, and now we have to activate the core by attaching some activated group at the surface. So if we, in the core, if we have the 3 branches, and we activate the 3 branches by activating groups, and then we do the coupling of another group on each 3 branches to get the generation 1 dendrimer having the 6 branches. Now see, in the generation 1, the number of branches are doubled from the core. Here in the core, we have the 3 branches, but here in the generation 1, we have the 6 branches. So now, again, the work is same. We will activate the surface of generation 1 dendrimer and again do the coupling with the same reagent to have the 12 branches. Now again in generation 2 the branches are double. It's from 3 to 6 to 12. Then again we will do the activation and it will lead to generation 3 dendrimers. And so on, it will grow. So this is the main principle behind the synthesis of dendrimer. So in next slide I will see. So this is the synthesis of my dendrimer. What we were doing in the group, we were actually working in the phosphorus chemistry, and we have utilized this phosphorus chemistry for the synthesis of these phosphorus dendrimers. And this is the crucial reaction behind the synthesis of this dendrimer, and we perform this reaction as an starting point for the synthesis of phosphorus dendrimer. This is the reaction. You can see it's a monomethyl hydrazine and thiophosphoryl chloride, and the coupling occurs at the minus 60 degrees Celsius in chloroform, leading to the formation of hydrazine-thiophosphoryl chloride. So in this slide you can easily see how the dendrimers are growing. We have the hexachlorocyclotriphosphaziene core, and we couple the 4-hydroxybenzaldehyde at the surface in presence of potassium carbonate, and leading to the formation of generation 1 dendrimer. You can see, no, it's a generation 0. We are just activating the group. We have put the aldehyde on the surface, and these aldehydes are then again coupled with the hydrazine-thiophosphoryl chloride. Then we again have the chlorine on the surface. Then again these chlorine will react with the 4-hydroxybenzaldehydes to have the benzaldehyde on the surface. Then again it will react with the hydrazine-thiophosphoryl chloride to have the 12 chlorine. In this way we can grow the generations of dendrimer. This is all for today's video. Thank you very much.